everyone. Welcome to a new topic, which is data cleaning. So this is one of the most important and honestly most underrated skills in data analysis. Real world data is almost never perfect. Like for instance, forms get skipped, systems glitch, people leave fields blank. If you fill the form, you know this. Before you can analyze anything, you need to find those gaps and decide sensibly what to do about them, right? So today we'll be looking at data cleaning, specifically finding and handling missing data in data cleaning, because we'll see other things that are also in data cleaning. But for today's topic is going to be finding and handling missing data. So for today we'll be working with retail sales data set that has some missing values built into it on purpose though. So it's on purpose so that we can practice on something realistic. So by the end, you know how to find missing data, understand why it might be missing, and apply the right fix for each situation, not just one fix for everything. So let's load the data set and take a look. I already have it here. Let's take a look at the head, right? So this is a customer order data, right? You have the customer ID, customer name, region, product, sales, the quantity, the rating, and order date, right? Just scanning the first few rows, everything looks fine. But definitely, missing data doesn't always show up in the first few rows you have in your data, right? You need to you need a proper way to check the whole data set. So let's take a look at what missing data looks like in pandas, right? So in pandas, a missing value shows up as NaN, right? Which is short for not a number. It's basically pandas way of marking there's nothing here. For instance, let's take a look at that info. Sorry, this is not, we use the sales rather. Uh, this is the fastest way to spot a problem. When you take a look at .info, it shows you the structure of the data, the whole data, right? Tells you how many entries you're expecting, how many columns are there, the names of the columns, and how many entries are in that column that aren't missing. So you're expecting 100 entries, right? So in order customer ID, you have 100, but in customer name, you have 95. This shows that you have like 5 missing uh, values. So just take a look at the not non-null column. In this non-null column we have here, we have 100 rows total. But if you notice this region, it shows 92 non-null. Sales shows 92 as well. Rating shows 92. That gap between 100 and those numbers, you understand? Like in the case of this 92, that 8 numbers is our missing data. So to see this more directly, we use a method called isnull, right? It checks every single cell and returns true if it's missing, false if it's not. On its own, that's a big grid of true or false, which isn't very readable. So what we do is we usually chain dot sum into it, which adds up all this. Let's just do it so that you see what I'm saying. Say you have the sales dot isnull. So this is basically a grid that checks where there is missing and where there is no missing, and it will only return true if there is missing data in that particular space. So all this true here, this true here basically means there are missing values. This true here, there, right? So but to make sense of it and add up all the truths so that you just see how many entries in each column are missing. You just chain the is null with dot sum, right? Which will sum everything for you. So this is basically what happening here that has been summed up. So where is true has been summed up. Customer ID doesn't have any missing values. So you have the customer name, region has 8 missing values, sales has 8, quantity has 6, rating has 8, order date has 4, right? So now we've gotten a clean summary. We've seen all the missing. This is always your starting point in any cleaning task. You need to know exactly what you are dealing with before you touch anything. And optionally, you can also show percentage too, right? The way you show percentage is that you say sales dot is now dot mean, the average, right, times 100, right? So let's, the use of percentage and it to one significant places. Yeah, yeah. So, so since we have 100 entries, the percentage is just going to show the same numbers actually, but this is in percentage. If the entries were more than this, it's going to show you the percentage, right? So your column missing 5% of its value is a very different problem, right? From one missing like 40%, you understand? So this is why checking percentage might come in handy. Imagine this is like thousands, you have thousands of entries and you're checking percentage. If one has 5% and another has like 40 or 30%, you see there's a difference between the missing values. So, but the next thing we need to look at is actually, let's seeing the actual missing rows, right? So knowing the count is useful, but often you want to actually see which rows are affected. So you can look for, if there's a pattern, you can look for a pattern, you understand. So for that, we take that same is null because it's our power move. We take that same is null, the is null check, and use it to filter the whole data frame. Instead of just summing it up like this, we are going to use it to filter the whole uh, data frame. So sales, all right. Um, no, let's look at the region and take a look at let's take a look at something. Sales. So let's see what is happening here. Let me zoom in a bit. What's actually happening here? So sales region dot is not true gives a true or false like it gives true or false for every row. It checks which entry is missing and gives a true or false, right, for every row. So when you now wrap the whole thing inside the sales, what's it called? The sales and open bracket inside the sales square bracket, it tells Pandas only keep rows where uh, this particular boolean is true, right? Only keep row where there are missing values in region. So now we are looking only at the rows missing in a region, right? Only the rows in our entries that is missing a region. Let's take a look. If you were to run only this, let's see what it will return. As you can see, it's only giving you row the entries of what's it called? It's giving you this the region column, and it's going to tell you where it's missing and where it's not, just the true and false value. But when you wrap the whole thing and you filter the data frame by this particular condition, it's going to give you only the entries, right? Only the entries where region is missing, only the rows where region is missing. Actually, I mean, so if you look at region here, all the entries here are missing. So basically, this is a data frame of only where region is missing. Obviously, you can see that customer name is also missing in 12, but what was used to make this filter, this data frame, is with where region is missing. You filter the data frame by where uh, region is missing. So, but the reason why you do this is you are trying to make sense of this because, as you can see, you just picked one of the columns that has missing values to take a look. You find that just take a moment and look at the product column we have here, this product column. You find that every single one of them is a books order, right? So every single one of the record here in the product column of this particular data frame where region is missing in our data, in the whole sales data set, is a books order. So this is not a coincidence, and it's actually one of the most important ideas in data cleaning. So let's take it, let's just slow it down here and go back a bit. So let's understand something. There are actually two types of missing data, right? We have two types of missing data. Missing data. So what are they? You have the random, random versus systematic missingness, right? So you have two types. So you have the random and you have the systematic. So before you decide on how to fix any missing values, you need to know what these two types is, and telling them apart would change how you fix missing values in your analysis. So the first is random missingness. So random missingness is basically where the gaps don't follow any pattern. Maybe a few customers just skipped a field with no connection to anything, right? Else in the row. If you look at your at this our particular sales or quantity columns here, the missing values are scattered across different products and regions with no obvious link. So this is random. Probably, if you look at even the customer name, it looks very random. It's not as if there's a reason. Maybe this person just decided not to provide their name and just left it blank. You understand? So it looks a bit random. That's what random means. There is no pattern you can tell out of that particular random data, right? But systematic missingness, in the other hand, is where the gaps line up with something specific. That's exactly what we just found with this region. That's why sometimes you take a look at when you have multiple columns, like here, you have multiple columns that are missing. You pick them one by one and you look at the data frame. Well, it's only those columns that are missing, so that you make sense of the whole thing. Maybe it's possible you might see a pattern when you look at the whole data frame with only those missing, right? So it's exactly what we just found with the region. Every missing value belongs to a book order, meaning what was bought were books. The customers bought books, right? So what could have happened? Maybe the checkout form for physical books didn't ask for a delivery region, or maybe books were sold in store, right, without that field being collected. Maybe it's missing. We don't know the exact reason, but the pattern tells us it's not random, meaning books products have no region, basically, or books products in most cases have missing values. So let's run this. Let's take a look at something. Let's do sales preferred one quotation, right? And then let's call on the, so we are filtering by region, and then we are doing value counts on the whole thing. right? Okay, yeah, yeah. And there it is. Literally 100% of the missing regions, right, are books. Even if you can't tell like this, probably the data is much. If you do this, you'll be able to tell that 100% of the missing region are books, right? So why is checking this important? Because if we were to fix this the lazy way, which is filling every missing region with with the single most common region in the whole data set, we are be putting a made up likely wrong region on every book's order, right? That could quietly distort to change a regional sales report. So if you have multiple regions and you just filled out the missing values you have for this particular book order regions and you just fill it out with the most common region, that means you are making things up. So understanding why something is missing should always come before deciding what to fill it with. So now let's talk about what is it called? Let's talk about the three families of solutions, right? What does this mean? So now that we can find and understand missing data, let's just talk about how to actually fix it, right? There are three broad approaches you can use to fix missing data. The first one, obviously, that I know might have come to mind will be to basically one, number one is basically what? Delete it, right? So you're looking at deleting it, right? What else? So what this means is that you drop the rows or columns that have gaps. It's basically just dropping everything that has gaps. Number two is what? Number two is for you to fill it with a value. So you just use a constant, a static like mean or median or something smarter based on grouping, right? We are not just talking about the original data missing values right now, in general. So, and number three is what? Interpolate it, right? So what this means is estimate the missing value using the values around it. So this works best for other data like if you have dates and the rest and the kind, right? So none of these three is automatically correct for every situation. But for this our scenario, let's apply each one to a real column in our data set and I will explain the reasoning each time. So let's go with method one, like we said, deleting it, right? Let's call this method one, which is what? Dropping to drop any, right? Let's see how it works. Let's start with dropping, right? Which is basically like deleting because it's the simplest, but also the one to be most careful with, like, right? You are literally throwing away data. Let's take a look at the entries we have with the shape. We use sales. I should have used yeah, right. We all know that we have 100 entries and 8 columns, right? We have 100 rows. That's what this means. 100 rows, 8 columns. Let's see what dropping rows with a missing. Let's use what is that? Sales value. Let's drop rows with a missing sales value. Let's see what dropping it will cost us, right? So how do you drop rows? You have a method called drop any. So let's create a new data frame so that we don't tamper with our data. Let's call it sales underscore dropped. So let's sales dot drop NA. subsets to tell it where you want to drop. Right. So this is like saying I want to drop missing values in this sales data frame subset, but the missing values in the sales column. So now let's execute this and see. So this will be a data frame exactly like this sales data frame we've been using so far, but with the missing values in the sales column dropped, meaning these missing values. It's where, sorry, missing, where, sorry, in the, with entries where sales is missing, dropped. You understand? So it will drop entries where sales is missing, is NaN basically. So what will happen is we would lose 8 rows, which is basically, let's take a look at what happened. Sales dot since as you can see, your sales has 100 entries, while sales dot dropped and sales underscore dropped. The new data frame we have has 92 entries. It means what it did it removed the rows where sales entry is missing. There's no column, there's no entry for the sales column. So it will just remove the rows. That's how you are missing now eight. You've now lost 8 rows, which is 8% of your data, just to fix one column, which is the sales column. So now watch what happens if we drop any row that's missing anything. Let's say we didn't specify the columns, right? Let's say, let's call it sales underscore dropped to. This time we are not specifying any column. We just want sales dot drop NA. Want to drop all the anywhere the rows where there is missing data, it should be dropped. Let's execute this and let's see the shape this time of sales dropped to shape. As you can see, look at this. If you drop all the missing values, you have missed many rows, right? You have missed what, 32 rows out of your 100 rows. So 32% of your data is missing. So this is a much bigger loss. So this is why blindly calling this particular drop NA on an entire data frame is one of the most common beginner mistakes, right? So you always check dot shape before and after. So you know the real cost of what you are about to do. So before you have 100 rows and now you've dropped, just because you want to drop the missing values, you've dropped 32% of your rows. All right, this is not going to work. So dropping is the right call when very little data is missing. Say under 1 or 0% of your data is missing and it's actually random, not systematic, you understand? Or when a column is essential and genuinely you can't be estimated. So, but we are not going to use drop NA as our main fix. I don't want you to know that it's important. It's an important tool for you to know, learn, right? So the second method we have, right, is what? Method 2, which is filling with a constant, right? So let's look at filling with a fixed value. So this works very well for text columns, right? Columns where you have strings, where there's no numerical average that you can fall back on, meaning like taking the mean and the rest. For example, let's look at the customer name. You know, customer name has some missing values, right? Why do I keep saying DF? I'm used to calling it DF. It has some missing values. has 5 missing values. So let's look at how you can just fill in these missing values with a method called fill NA. So what will happen is that you can have a new customer name. Let's just fill this. Notice that before, customer name has uh, 5 missing values, but when you fill it with, let's say you called it unknown, let's not even give the gap, let's say unknown customer, you find that the customer column, anywhere there is missing data, it will be changed. Instead of leaving that place as NaN, it will be changed to unknown customer. Let's take a look at the customer column only. First and foremost, let's see, do we still have missing? We can copy this and use it to check here. As you can see, you now have 0 missing values because you filled those missing with unknown customer. You can even take a look at this by okay, let me just copy this. All right. Do we have, yeah, look at it. At 97, you have unknown customer there. So this was actually missing before, but after filling it with the text string unknown customer, you no longer have missing values there. So it's better to label the gap instead of just pretending to know a name that you don't. Maybe you just decide to fill it with another name. Abdullahi Isa or something is wrong. So you just fill it with unknown customer. It's better that way. It's not a significant column to your feature to your data set. It's just the names of the customer. So it's better that way, right? So the third method, the second method is filling the gap, right? The missing value. The first method we saw is dropping the missing value, which is with drop NA. We are now seeing filling it with a constant, which is fill NA, right? And the third one is method 3 is going to be filling with mean or median. How do you do this? Say, let's just say you have numeric, of course, we even have numeric columns here. So for numeric columns, we usually fill with a static, let's say, what's it called? A statistics. But which statistic matters? You know, mean, median, is statistics now. You obviously, data science, you should know, right? Which statistics matters? Let's let's check the sales column and see what we are trying to. Let's use the sales. I think we have sales. I shouldn't have called this data frame sales. Let's let's call this because of the column we are going to use. Let's do this. All right. So we fixed customer name. So instead of using sales, I've changed it to data frame. So let's go with data frame. Hopefully, if you don't keep this. So let's look at the sales. You know, inside our data frame, there is the sales column. So I was trying to, I don't want to mixing it up. So let's look at the sales main column, sales.main column, and then the sales, the df sales.median calculation. Right. So if you look at this, the sales itself, let's also look at the sales column. The sales itself, this is the way the entries are. Let's just look at two of the entries, look at it, and it's a sample of what the entries look like, right? So sales.mean is 28,029.67, blah, blah, blah. While sales.median is 26,342. So if you notice, these two numbers are not the same. This tells us that the data is a little skewed, likely by a handful of unusually large orders. We'll see that when we get to that. So when that happens, median is the safer choice because unlike the mean, it isn't pulled around by extreme values, right? It tries to stay in the middle. Unlike mean that will take the average. You know, mean is average now. So when you have cases like this, you fill with the median instead of the mean. In most cases, when you are filling in numerical values, it's easier to just fill with the median. Let's see. Uh, let's say we want to fill in the missing values in the sales data sales column. So this time we are not filling by unknown, so we are doing fill NA still, but by what? DF sales dot median, right? So what this is saying is that I want to fill in the missing values in sales. Mind you, sales has missing values, right? Let's see how many missing values sales has. Is NA is now dot sum. Let's change some there. It has 8 missing values. So you are saying these 8 missing values should be filled with the median value of the whole sales column. So that's what you are saying. You want the new sales column to be the sales column that has its missing values filled with the median of what's it called? Of the sales column. So it will be filled with this, basically, is what we are saying. So when we execute this, you find that when you run this again, you don't have any missing values in the sales uh, column, right? So apart from that, what other column do we have missing? We still have missing. We've done two, no? We've done customer name, we've done sales, and then which of these is also numerical? Let's look at our numerical column. Dot info. So sales, we know sales is definitely numerical. All right, so quantity is numerical and it has 6 missing values. Let's look at handling quantity as well, right? So let's redefine quantity. Let's also fill it with the median. So it's going to be the quantity column dot filled with what? What is the median of the quantity column dot median, right? So the quantity column is going to be the quantity column filled by the median of the quantity column. So we can even take a look at confirm if we still have missing values in the quantity column after doing that. As you can see, you now have 0 missing values because what's missing has been filled with the median, right? So we filled in, where is our general checkup? So we filled in customer name, sales, quantity, right? We still have rating order and the rest to do. So let's um let's let's say now let's look at rating. Yeah, we have rating with 8 missing values. But let's first check what's missing in rating, right? Let's filter the data frame by the rating column that has missing values, right? We did this before. What is this? What is this? Yeah. What did I do? Yeah. uh So let's look at the rating column, right? So we have if you look at this, you can make sense of it. When you are not sure, like this sales column and the quantity column, since it's easier to just fill them in, but rating is basically the rating of. And so when you are not sure, you take a look at the where the rating is missing in the whole data frame. So if you take a look at these entries that are missing, the eight missing rows where rating is missing, you find that this is actually a block of consecutive rows, right? It's arranged. Look at the index. Row 20, row 21, row 22, row 23, up to row 27. These are where rating is missing. So what happened is this is probably a systematic pattern, right? Since it seems like there's a pattern to it, it's not random. Rows, consecutive rows have missing values. So there might be a problem. You might not be able to tell exactly what the problem is, but you do know that it's systematic. It's not random. So it might likely be a period where a survey tool or feedback form went down, right? So this is rating, you understand, like customers rating the services and the rest. So maybe the feedback form went down, so it's not scattered. Maybe it's not as if the person skipped entering that record. So in a case like this, if you are filling with the mean, it might be reasonable to just fill with the mean. But let's see if there's an equally valid alternative. Could it also be okay to just leave this as missing and maybe we just exclude them from any, maybe if you have any rating based analysis you want to do? Since this is rating, right, of customers, and if we just fill it with something else, we are not being honest, right? Because we are just inventing opinion that nobody gave us and we are trying to see people's opinion. You have eight customers that didn't give their rating, or for whatever reason the system is down. So probably you want to leave it as missing, or you might fill it with a text like the unknown customer we gave and maybe it's not given or something like that, I think. So but for the sake of this our, let's just fill it with the mean average rating that was given in the whole data frame, right? So how do you know? We say to get average is just calling on the column and then dot mean, right? To give you the average. So the average rating of the whole data frame is 3.007. So let's just let's fill it. Let's fill the rating column with the average rating. Rating is equal to df rating dot fill any. What is the fill any? Df rating, where rating, that's mean the mean of the rating. So you can take a look at rating. Uh, is any, what's, so you no longer have missing values in the rating column. So you use mean or median for numeric columns when the missing values look random. So you reach for median specifically when you notice skew like we did with the sales column. So the next thing on our the next method is interpolation order data. This is our fourth method, right? So what does this mean? But I think before we talk about interpolation, I think we skipped a column that has missing value and how to deal with it. So we have region. It still has missing values. So the easiest way we can deal with this is to define region to be equals to region dot fill NA with what? Region, no, with unknown. We don't want to be dishonest because when you look at the whole data frame, you might have a region that is common. For instance, let's look at the whole data frame. df, okay, yeah, I have region here, dot mode will give you west. So west is the most common region in the whole data frame. But you are looking at, if you fill it with west here, you might be creating a problem because you don't know if it's actually region missing values in region is systematic because we found out that those are bought books that have the region missing. So you don't know if all the books were bought from the western region or not. So it's better to just leave it as unknown, or if you'd like, you can just fill it with the west. But I think it's better to leave it as unknown. And so if you want to fill it with the most common region, you can just take this and instead of unknown, you put that there, right? So it will fill it with west instead. Or you can might as well just fill it there yourself. So, but for our own data frame, we'll be using unknown. Sorry, yeah, unknown. So let's execute this and then let's take this and take a look at region again. Now we have 0. So let's keep going because the only this thing we have left, the only column we have left, it should be, yeah, order dates, right? Now, we left a lot of things up intentionally because I wanted to discuss them last when we come to interpolation, right? Now, there's a method in Pandas, which is in Python actually, especially Pandas. Let's say Pandas, not in Python. Pandas, which is interpolate, right? Interpolate. So interpolate treats your data as points on a number line, and it fills gap by drawing a straight line between the nearest known value, right? But let me give you an example. Let's import NumPy. We don't have NumPy here as MP, so that we can create a simple series that goes from, let's say, 10. The reason why I'm importing NumPy is I need null values, and NumPy, you can easily create null values with NumPy, right? So yeah, so I have this. If you take a look at S, you find that you have two unknowns. So if you want to interpolate this data right now, and you redefine S to be equals to S dot interpolate, you can read more on this, but we'll just use this. I just want you to understand what is about to happen. And you take a look at S, look at it right now. You see what happens, right? Pandas, Pandas just evenly spaces the missing values between 10 and 20 and 40, right? Treating each row as one equal step regardless of what the values actually represent. You understand? So interpolate can only do math on numeric data types. So you can't use this on text. It can't average two strings, you understand? So for that reason, if you take a look at, let's take a look at df.info again. We are trying to fix order date, the last thing we have there. Order date has four missing values, right? But if you look at it, it's an object. It's not a numerical data type, right? So we are trying to fix it because it's date. You know it's date. So because if you look at dot head, you can find order date there, the dates of the orders. You understand? Even though it still has missing, you can even take a look at where it's missing, right? Uh, Order dates dot is null, right? Right. So let's do this. So you have four missing order dates, right? They are not arranged basically. So you want to interpolate, since you know the way orders will be arranged. If you look at the orders, there will definitely be some pattern to it. So instead of just filling with maybe an average or something, you need to interpolate. But right now, order dates, if you check the data type of order dates, you find that uh, it's an object, right? So the way to fix this is you need to make order dates a numerical data type, but it's dates. You can't just change it to numerical data type because you have, I'm sure we have yeah, hyphens in the dates, right? So we need to convert this to a date type. There's also a date type in Pandas. So I should have done that right from the start, but I left it out so that when we're done, it won't come as something you don't know what is being done. So instead of that, we'll pass dates, tell it that it's the what order date column. Sorry, order dates. Right. So since we've done this, I think we should rerun the uh, whole cell so that right now, if you check df.info, you'll see that date is no longer what's it called? Object is a date time what's it called? Data type, right? So this is going to be easy for us to interpolate right now. So let's go back to our method 5, which is the interpolation. We will interpolate on this particular data to to fix values to the four missing values, right? Because we have four missing values in the other date. We can now easily use interpolate because, like I said, interpolate, like with the example we saw here, would only work on numerical data because it can give you a fixed number, space it, and give you the number. Like you can see the sequence 10, 20, 30, 40. So we want Pandas to also do that to our date. It should look at how frequently orders are made, and then it can interpolate and give us the data there. So the way you interpolate, um, first and foremost, let's sort the values in our data set. Let's sort values, right, by order date so that it's arranged. And then we set index is equal to true. You should have recalled what reset index does. So let's save this first. Let's see what the head of our data frame looks like. So Ideally, it should now be arranged by dates, right? As you can see, it seems it's even the last 4 dates that are missing. It's the last 4 dates that are missing. So I use the tail to check the last ending of the data, and it's the last 4 dates that are missing. I didn't even know that. So now let's interpolate with, instead of using drop or fill any, we are going to interpolate and have pandas fill it up for us. So it's going to be df order dates dot interpolate method linear. Of course, it should just be a linear interpolation. So now when you look at whether order date has missing values, you find that it's now 0. So if you take this and you run it again, you see what you have towards the end. So it's basically the same dates. So I don't know. Let's see the last 10 so that we can. So it filled it up with the same dates. Who knows? All right. So that's how interpolate works. Our orders happen roughly every 3 days actually. So this is what we have in this particular uh, data cleaning class. All right, so before you end everything, the next thing, if you are doing data cleaning, you need to confirm if what you've done, this is non-negotiable. You need to confirm if your cleaning was actually worked, right? So it's not that sum should return 0, 0 for all the columns. Now we have cleaned this particular data frame. So it's now time to save it, because if the only job you had to do was clean it, the next thing to do would be to save. How do you save? You can save a data to CSV, and let's call it you now add the name retail sales, and let's call it clean, right? Dot CSV. Now the problem of pandas is that if you just save it like this, it will save with the name, with the index, right? So we don't want that. So what we need to do is tell it that we don't want the index, because these numbers will go with it. So we'll tell it that index false, we don't want the index to be included. You will find that this will be saved in the same directory as your data, right? You'll find it in the same directory. So, and my directory is actually the documents. It's in my documents. So, yeah, as you can see, I have retail sales underscore clean here. Let's even take, let's check it out. Let's use Excel to check it out. As you can see, we have the data here right now. We have our data, right? You have everything, the 100 data all cleaned, everywhere filled up. You understand? So that's how you carry this out. So let's go back to our work. Yeah. So the way you know how to choose the right method, the first thing to consider is how much data is missing. If it's tiny and random, dropping that data might genuinely be fine, right? So the second thing is it random or does it line up with a category? If it lines up with something like our books and reading example, investigate that group before you fill anything. The third thing is that the number three is what type of column is it? Is it a text? If it's text, it gets a clean constant label. If it's skewed numbers, it gets median. Evenly distributed numbers can get the mean. You can take the mean. If it is ordered data like dates, uh, it gets interpolation, right? So maybe if you make a wrong guess, it might actually uh, cause a problem to your analysis. It's honest to just label something unknown if you don't know, right? Than just inventing something. So there's no single right answer for every data set. The goal is being just for you to understand that these are the choices you have, and then you can make the right call. With that being said, I think we left something out again because we have rating. We did something wrong in rating. I think is it rating? Okay, it's not rating. It's fine. Or is it quantity? What did we use to fill out quantity? I thought no, it's not. Let me take a look at this. It's rating. Yeah, it's rating. So the rating, we didn't round it up because the rest of the rating has 2.6 just to one figure, significant figure, and then we are having like zero, zero, and a lot of figures there. So decimal places rather. So we need to round it up to one decimal. Where did we fail the rating? Yeah, that mean probably we should have added dot round and put one there. So I will run the whole thing so that that will be carried out at the same time. So yeah, this will return an error because we already have a data frame there that is called that. Let's name it true. Let's name it true. Let me remove this. We don't need it. I'll name this true. Retail sales cleaned 2 so that it will work. And we can as well go back to our documents and take a look at it this time on Excel. Uh, oh, sorry. I placed it here instead of here. Yeah. So this is wrong because I changed the extension this way. Looking at this. So so our rating is better now. It's better. It's better. It's better. It's better. It's not giving us those figures, right? So it's okay. Unlike here, that it's giving those figures. So that's it for this session, right? So we'll meet in the next class, and we'll meet in our next live class we have. You can call it a day here. Thank you for watching.